field is emerged due to receive terminal arrangement. The applied negative voltage in discharge electrode is increased until it produces coronal discharge, which can be seen as a luminous blue glow around the discharge electrode. Due to the formation of coronal discharge, free electrons are emitted with high velocity from discharge electron. This fast-moving free electron strike the gas molecule. Those emission of free electron for gas molecule move toward discharge electrode by electrostatic attraction. As a result, using gas molecule, more free electrons are emitted near the discharge electrode. Electrostatic precipitator or ESP is used for effective filtration or control of particulate emission. It is a filter that removes minute dust particles. ESP can collect dust particles from 0.1 to 10 micron effectively. They are efficient than cyclone and scrubber for collecting particulate suspended matter from air or gas content. Second stage, as electron leave strong electrical field area around discharge electrode, they will start slowing down. These free electrons again strike gas molecule, but this time they are captured by gas molecule and become negatively charged ion. As gas molecules are negatively ionized, they move toward positive electron, for example collector electron. This negative gas ion fills space of dust particle and becoming negatively charged particle. These particles are captured by collector electrode using electrostatic attraction.
First, when you start the experiment, make sure that the EP filter, the collection plates and the pre-filter, the honeycomb-like filter is clean and free from dust that will block the surface of the plates. Alright, next, for the sample preparation. First, dismantle the feeder cover from the cone-shaped feeder, then weight the cone-shaped feeder on a balance. Reset the balance to 0, and then fill in the feeder with 50 grams of kaolin powder. And then take the filled cone-shaped feeder and attach the cover onto it. Reset the balance to 0 and then weight the cover filled feeder on the balance and record the reading. Weight the clean pre-filter on a balance, take down the balance reading. Put the pre-filter in the equipment and lock it to prevent from falling. put in the EP filter in the equipment. The well-cleaned EP filter is supposed to weigh around 13,000 grams. Make sure that EP filter is not too close to the equipment walls and the door to prevent from short circuit. And then reset the balance to 0 again. This time the balance reading is set to take the weight of the particles that will be collected by the EP filter in the experiment. Connect cable 1 and cable 2 to the EP filter, which cable 1 is on the front door and then cable 2 is at the top door. And then close the front door and the top door. Plug in and switch on the equipment plug to the main power supply. After 30 minutes, take out the EP filter and put it aside. Carefully take out the pre-filter and try to prevent the trapped particle from falling to a minimum rate. Wake the pre-filter on a balance and write down the reading. Alright, next is clean the EP filter, pre-filter and the chamber from kaolin powder. Repeat the experiment with atar flour for another hour.
Okay, so these are the factors that are affecting the efficiency for the electrostatic precipitator. Firstly is the dust concentration. Dust concentration can affect seriously the efficiency because the more the concentration, the less efficiency. For example, if we use atar flour is more concentrated than kaolin flour. So as you can see the result later on that atar flour has less efficiency compared to kaolin powder. This is because the atar flour can block the corona, can cause corona blocking, and also the secondary current can also drop up to 0%. Okay, next is the gas humidity. Gas humidity has significant impact towards the collection efficiency. This is because the higher the gas humidity, it will activate the particle surface of the dust. So, for example, if there is water, the dust will agglomerate into a bigger particle, which is easier for them the collection to occur. So the more humidity, the better the collection efficiency. Next is the dust specific resistivity. So the specific resistivity have a critical impact on the performance of this ESP. The range of resistivity should be around 104 ohm cm to 1011 ohm cm. Because anything lower than 104 ohm cm will meaning that the resistivity is too low, which can cause the particle to go out from the precipitator, whereas anything higher than 1011 ohm per cm can cause secondary blowing, which is quite dangerous. The dust specific resistivity also depends on the dust components. Some components such as disodium oxide, which is Na2O, or dipotassium oxide, Ka2O, have lower resistivity compared to aluminium oxide or calcium oxide or magnesium oxide. So that the efficiency also depends on the resistivity. of the dust component itself. Inside of the plate. So sorry. Therefore, next is the dust cleaning mode. So you can see this inside this contains the plate. So as time goes on, the efficiency of dust collecting will drop. So basically, there are several ways of cleaning mode, such as vibration force. As for our mindset ASP, they just use the air blower, which can cause the deterioration or the efficiency of this plate. So another mode can be used is acoustic wave. Acoustic wave is better and more efficient, as it will vibrate the plate and by sending acoustic wave, which will take a bit more time, but it's more efficient and more safe, as it can make this plate last longer. So for sending the acoustic wave, low frequency acoustic wave, the dust or the particle that stick to the plate will eventually drop bit by bit, and this is a best cleaning mode so far. Power supply. Power supply with higher frequency is more stable compared to lower frequency, because it can make you can work stably for a long period of time, because this power supply is the high frequency is around 20 to 50 Hz, which is the most efficient frequency.
There are 4 recommendations can be made to improve the efficiency of the ESP precipitator unit. The first one is corona blocking may occurs under high dust concentration. So, a pre-dusting facility is necessary. Secondly, gas humidity has a significant effect on the ESP performance. Water spraying can improve this, especially under the condition where high dust resistivity occurs. Thirdly, acoustic wave dust cleaning mode should be available. It can improve the ESP collecting performance effectively and economically. Lastly, high energy power supply can provide nearly direct current. Its output can provide a higher energy stable.